Hello, everyone. Thank you for taking the time and listening to this webinar. My name is Arianna Bozzolo, and I'm the Research Director at the Rodel Institute California campus. Today, I will present the data that we'll gain from the what we call the Healthy Soil Project. That, as you can see on the bottom left, this project was supported by the California Climate Investment. This is a state program. They promote sustainable practices and reduction of greenhouse gases. For this experiment, we worked with pumpkins and Bilko cabbages, also called Napa cabbages. And yes, I'll go ahead and start the presentation. If I can. There is some housekeeping before. I hope you can hear me. If you're not audible, you can check on your audio setting and see if you can fix the problem. If you cannot fix the problem, feel free to call the Rodel Institute Educational Department. As far as question and answer, if we can do it everything at the end of the presentation would be great. Even because I don't see the chat. So I will check the question and answer at the end. You can also send me question later on at my email address if you don't want to do it right now, if you have questions later. And this presentation is recorded and will be posted on the Rodel website in a week, and you'll find it also on YouTube. This presentation are also part of the requirements for the Healthy Soil Program, so thank you very much for attending it. As you can imagine, we will talk about cover cropping and the high residue reduced tillage, but I wanted to share with you these slides before to start the whole presentation about the research project, because I think these slides kind of remind us why not this specific research is important. In general, research about sustainable farming practices are important, and also it's very important also when the farmers actually implement these practices, because we do all of this to have a healthier life and eat healthy food, but also breathe healthy air. And I was reading the California Department of Pesticide Regulation results. These were for 2023. And I saw this table. And as you can see on the far left, there is the column that is the community. So the California Department of Pesticide Regulation, they monitor the air quality all over California. And then they do this report, and they reported that in some of these cities, California cities, the chemical pesticides were detected. As you can see, Shafter, Oxnard, and Santa Maria are in this table. Shafter and Santa Maria are about 130 miles from the COC, the California Organic Center, but Oxnard is our neighbor. So whatever people are breathing in Oxnard, we are breathing it here in Camarillo too. And as far as chemicals that were detected, we can find fumigants, we can find fungicide, neonicotinoids, so insecticides, methyl bromide that was banned a long time ago, but it's still found in the air. And again, in Oxnard, we have the pendimethalin, that is an herbicide that should not be in the air. Then we have the date when the samples was taken. This is the highest concentration in 24 hours. And on the right, the screening level is our safety level. As you can see, there were no danger, no screening level were none of the sample were beyond the screening level. But I also added another slides that how these screening levels are decided. So the safety limits for pesticides are also known as maximum residue limits, MRL, or tolerance. How these numbers are determined. There are toxicity studies. Scientists study the pesticide effect on animal and human to find the highest dose that does not cause harm. On mostly rats, the pesticides are tested on mostly rats. Human, they do not test directly on human, but they collect data if people claimed intoxication. They go to the hospital and they recorded those data, and then they will be used for this study. There is always safety margin that is added, so about 100-fold or more, because we are heavier, I think, than rats. Then we have the acceptable daily intake that uses, sorry, I have too many bars. The non-observed adverse effect level and safety margin to calculate the risk, the lifetime risk based on our daily intake. So the eating habit as well, exposure assessment. So researchers estimate how much the pesticide, how much of the pesticide people might expose to based on what we eat. And based on these of modeling these numbers, we come up with the tolerance of the maximum residue limits that the pesticides can have on fruit and vegetables. One thing that I need to point out, that as it says here, for each pesticide and its specific crops, and well, we are supposed to eat 30 different vegetable and fruit in a week to keep our biome healthy. So these calculations are done on a single crop with a single pesticides. First, I think I don't eat only one type of crops. And I need also to add that when we spray pesticides in the field, rarely we go only with one. If I can save a pass of the tractor in my orchard or in my field, mixing multiple pesticides, I will do that. But this calculation, these limits are never monitored, never calculated based on the combination of active ingredients. So said that, I think these are really useful tools. All the pesticides we have, herbicides, fumigants, I just think they should not be used like a day-by-day routine. They were weapons, and I think they should be used as a weapon. All right, now we can talk about cover crops, way more fun. So cover crop in vegetable production, the purpose of cover crops: improve soil health. We improve soil health, increasing organic matter, and consequently the fertility of the soil increase. Cover crops can also reduce erosion, suppress weed, break disease cycles, that is really important, rotation, promote beneficial microbial activity, and boost biodiversity. Yes, cover crop can do all of these good things to our soil, and with other sustainable practice, such as the reduced tillage, the rotations, the use of compost, it really can improve the quality of the soil and our products or our production. We also say promote beneficial microbial activity. In general, the microbial activities is calculated in several ways. We just call them microbial population. Most of the time, as far as I did in the past, when I need to understand if a soil contain, how much microbial activity a soil contain, we take a fresh sample We take it to the lab, we analyze for carbon, then we fumigate it with chloroform, so we kill everything is alive, and then we analyze again for carbon. The difference between the two is my microbial activity. This is the one of the, is not that cheap, but one of the more easier way to measure the microbial activity and the population. If we, it is also possible to go more into detail with other type of analysis to see which type of microbes we have, fungi, bacteria, actinomyces, and on that area we'll need to do an analysis more like PLFA, polyfatty acid analysis. What are high residue reduced tillage systems? We know that cover crops, when we planted them, we let them grow, and then we can manage it in a different ways. Most of the time are incorporated with the soil, with the rototill or plow, and they really do a good job in that way too. But there's also another way, the high residue system. This system started probably before that, but has been becoming more popular since the Dust Bowl, because scientists were trying to find solution to keep the soil on the ground. And they found that the high residue system, it really works very well with to reduce erosion. We have every year more and more acreage that are farmed in this way with the reduced tillage system, both organic and conventional. Brazil is a great, is one of the pioneer of the reduced tillage, no tillage system. So what it is, a high residue system retains cover crop biomass on the field surface, providing a thick mulch layer. Benefits could include improved soil moisture retention, better weed control, and temperature regulation for crop growth. Some of the most common choices for cover crops, oat, vetch, and peas. These are the cover crops that we use in our experiment. They are popular in high residue systems due to their biomass potential, because that's what we are looking for, a lot of biomass, sufficient biomass, nutrient contribution with the root system they have, and during the composition, and compatibility with various vegetables. I added that because oat, vetch, and peas are have a relatively low allelopathic effect, so it's easy to either include them in the rotation or use it as an intercropping. So the oat works very well with leafy green, brassicas, and root vegetables. Peas works very well with beans, other beans, and cabbages, and vetch seems very working very well with pepper, cucumbers, and tomatoes. So they can easily be intercropped or included in the rotation with with vegetables. Here is a little, we will see a little bit more in detail each of these cover crops. So oat is we picked oat because I know it can produce a good amount of biomass. It can produce from 4 to 6 tons per hectare, depending on growing condition and soil health. Provides a ground cover, helping suppress weed and conserve moisture. This is in the picture is actually our experiment. This is the mix with vetch and oat. You can see there's some weeds in the mostly on the edge here, but it it does really work fine with the suppressing weeds. It has a strong root system that improves soil porosity, infiltration, and aeration. Oat is not a legume, as we know, so it doesn't fix nitrogen, and that's why we tend to mix it with the legume. tend to regrow in warm climate, which may require additional management in some system. That is my big issues. It bounced back, especially when I used the roller crimper alone. The problem of the bouncing back or regrowth is that it kind of reduced the effect of weed control and also compete with my cash crop. Veg is it's a really interesting legume. It produces a lot of biomass and it contributes significantly in nitrogen. It can fix in between 50 and 150 kilograms per hectare. I know it's all on the metric system here. So we can reduce the fertilizer for the following crop. It's ideal for improving my soil microbiology activity and organic matter, promoting soil fertility in vegetable system. Often pair with the cereal cover crop like oat to balance carbon nitrogen ratio for an optimal residue decomposition nutrients. And that's another reason why we want to mix a legume with the cereal, because the broadleaves tends to decompose faster, tends to regrow, and so sometimes it becomes a weed. So it's really interesting because of the characteristic of the biomass. It climb on top, climb around the oat. So ideally, when we crimp it, the oat will keep the veg on the ground, but sometimes it doesn't. But in theory, it does. And then we have peas. Peas is one of my favorite cover crops, or crops too. They can produce a good amount of biomass that goes from 3 to 5 tons per hectares. It adds nitrogen to the soil from in between 50 and 100 kilograms. So it's a little less than the veg we just saw for veg. It contributes with organic matter, supports soil structure, water retention, provides a good weed control, and works well in cool season, and is commonly paired with oat to balance the biomass and nutrient cycling. I really like peas as a cover crop because it does really produce a good biomass, and also here in California, the pea tendrils are used for direct marketing. And so while we are waiting for the cover crop to grow, farmers actually seed the peas just to harvest the tendrils. They don't wait for the pods to be formed, and they just harvest those pea tendrils, so the shoots, and they can be sold, I think, about $3, $4 per little bunch. So it's a good extra income if you do the direct market. Here I put some common cover crop in order of biomass production, just to have an idea where we are at with the oat pea and oat veg. So the sorghum Sudan grass is the one that produces most biomass. Here it has been reported 8 to 12 tons per hectares. And we use that for another experiment for the strawberries. Well, we reached 18, 20 tons per hectare, and some recently asked me if it can be, if a biomass can be too much, and well, I think it cannot. The 20 tons per hectares that we got from the sorghum for the strawberries, they last really a long time. The only problem I foreseen is rodents. But if you have other opinion, please feel free to share. I am open to discussion. Then we have rye. Rye is performing really well too here. 5-10 tons per hectare. We used, I have some picture later, we used for another experiment. It can, and it suppress weeds even with less than about 5 tons per hectare, good weed control and good biomass production. We just saw the oat is oat growth really quickly, strong with suppression, hairy veg. It can produce in between 3 and 5 tons per hectare. Good nitrogen fixer, field P, we just saw it, and they work well with oat. We also tried the crimson clover, is one of my favorite too. Not really much for the biomass, but because of it self-terminate, is annual, and it after termination, when it finishes life cycle, it leave a lot of residue on the top of the soil that they do some weed control as well. And then we have the buckwheat. Buckwheat is really nice as to implement the biodiversity. Bees really like buckwheat and other insects. It's really quick, and it doesn't do, to me, it doesn't do the job. It doesn't produce enough biomass for what we are looking for. But other scientists, I saw webinars where they had a different results with the buckwheat on the East Coast. So it really depends. But the threshold varies when we do the high residue system, but in general, at least 4 tons per hectares. Now, I know that I'm working with tons per hectares, so here I put like a quick list of numbers. So I have legume, grasses, and mixture in ton per hectares and in ton per acres. So in the next few slides, I have at the graphs when I will show how much biomass we produce, and they're all in ton per hectares. I would say it is about, the ton per acre is about half, a little less than half the number in ton per hectares. In this picture, we have Dr. Pichenka with the meters. This is the rye, 4 feet. And according to our calculation, our data collection, we had 50 grams per square foot because we take the samples with the square foot square, but we measure in grams because they're more precise than pound, and is about 5.4 ton per acre and 2.2 ton per acres. And it did really well as far as weed control. Now let's get to our experiment. Sorry. Now we want to, in this experiment, we wanted to evaluate the cover crop biomass and the roller crimper technology for weed control in vegetable system. As I said, we tried with the pumpkins, the Howden pumpkins, actually. This one on the right were ours. And let's start it. So materials and method. The experiment was conducted in 20 randomized plots. Each plot was 46 by 12 meters with 4 applications per treatment. So we're about like 100 feet by 30. So it's a pretty big experiment. This experiment takes the whole, most of our field is about 3.5 acres. And these 3.5 acres are divided in 20 blocks, basically. And we have 5 treatments. So we have the bare control, so no cover crop, and standard tillage with rototiller. That's our control. We have oat and veg, oat and till, and oat and veg, oat and till, oat and pea are tilled or no till. So the no-till we use, for the no-till we use the roller crimper, and for the tillage we use the rototiller. Here you can see Reina working with the rototiller and rototilling the cover crops. The cover crop were planted in March with a drill. So 15 centimeter row spacing, and the seeding rate was 100 kilograms for oat, 135 for peas, and 22 for veg. We use the sprinkler irrigation to germinate it, as you can see on this picture on the top. It works, but when the cover crop gets to 2 feet, the sprinklers are too short, so there is no way to irrigate them anymore. And after the implementation of the treatment, we went with the drip. Then cover crops were terminated 90 days after seeding. No till plots were passed twice with the roller crimper, while the tillage and control were passed twice with the rototiller. Pumpkins, the variety Howden, were direct seeded in July and harvested in October. And after the pumpkin harvest, we went with the cabbage. That were seeded in November and harvested in February 2024. As far as data collection, we started with the soil. We have the baseline in March 2023 before to start everything. And then we have, I took again the soil sample right after pumpkin harvest and then after cabbage harvest. So from the first to this last one, 1 year went through. Then we calculated, we measure how much biomass we produce before to terminate it, after termination, and at pumpkin harvest. And we did this both here, 2022 and 2023. I do not have one of the above ground biomass for the 2024 yet, because I think they're still drying. And then I have a yield and yield component for the pumpkins and for the cabbages. For the pumpkins, I have 2023, 2024, and the cabbages only 2024 because we transplanted them about 3 weeks ago. Down here is like a sort of a timeline. So we started in March with the soil samples. In June, I took the samples for the biomass before termination, after termination. In October, we had another soil sample, another above ground biomass sample and harvest. And then in February, I have the cabbage harvest. And then we have the soil samples analysis after 1 year. And this is our starting point. This is the soil baseline. We are dealing with the Camarillo sandy loam. These samples were collected as I did all the samples later on. So every block were subsample at least 5 times, and then they were all combined, and then I usually send it to the word lab. So I have the soil baseline for all the blocks separately, and then I average them on my Excel sheet. I ran the ANOVA, and there were no differences in any of these parameters at the beginning of the experiment. Okay, so here we are dealing with a pH 8, so relatively high. Low EC, I think is because we took the samples right after the rain. Right after we had a substantial rain. Usually we get rain like in January, February, and then we took the sample like in March. Organic matter 1.4, pretty low. Nitrogen, yeah, is still on the low end. The rest of the micro and macro element are within typical ranges. We are a little high on the potassium with the 200, and a little high with the magnesium and calcium. The other are relatively balanced, but we are not completely off. CEC is balanced. 11, or on kind of on the low end. We are on a sandy soil. And these are my routine analysis. And then as far as soil health, we have organic carbon, organic nitrogen, the ratio between the two, CO2 soil respiration, and total nitrogen. Here I have the value for the epoxy, the ammonia, water aggregate stability, and soil health in general, and microbial active carbon, but I have it only for the soil baseline, and we'll do this analysis at the end after the cabbage harvest this year. So I will report it basically only this, the organic carbon, organic nitrogen. The organic carbon is that carbon that is available to the microbes, but they are not directly available to the plants. We'll need to go through a microbial mineralization to be able for the plants to uptake it. Same for the organic nitrogen. The soil CO2 soil respiration measure the microbial activity, how much these microbes that are in the soil are working, are breathing. Okay, and this is my soil samples in October. So we started in March, then we seeded the cover crop, we water, grow them, terminate them, grew the pumpkins, and then I got the samples. We can see the organic matter, I don't see significant difference between the treatments. Sorry, I need to explain the bars for a second because all the graphs will be similar to this. On the far left, we have both the no-till cover crop, and then we have the till cover crop with the polka dot colors, and then the bare soil on the far right in that tan brown color. So the no-till on the left and the till on the right, and then the bare soil. So I didn't see any significant difference between treatment. I could see that if you remember, we started with a 1.4 organic matter. Now we are on a 1.7. So I could see increase across the board for the organic matter. Nothing specific for any treatment. For the organic carbon, so the carbon that is available for the microbes, I have even here, we have a slight increase because we were at 134 before, and now we are in between 130 and 160. So we have a slight increase pretty much everywhere. A little bit more increase in the oat and veg till. As far as soil respiration, we started at 50 in March, and here I would say I have a lot of variation, but we have a decrease of soil respiration overall in the time, over time. So I have an increase of organic matter, organic carbon, but the microbes are not, they didn't increase yet. For the total nitrogen, I have a similar trend. So the total nitrogen content in October, it was similar to the baseline, but I have variability across the treatments. I see the oat and veg till that is a little higher than the other, is not statistically different. So oat and veg till has the highest total nitrogen. Oat and veg no till and bare treatments show only a slight decrease. And oat and pea till and no till have a lower total nitrogen value. So oat and pea or oat and pea till and no till are the lower, but there is no significant difference. The organic nitrogen show a slight increase across most treatment. So increase of the organic nitrogen from March to October. And I think we started with the 12 ppm, and now we are about 13, 16. So far we could see that the carbon, we have a slight increase on the total carbon and the organic matter, but no a slight decrease on the life of the microbes. While for the total nitrogen March and October were the same, but I can see a little bit of more nitrogen at the oat and veg teal. Now we are looking at the graphs for the biomass before termination. So oat and veg, oat and pea, the treatments were not implemented yet. So again, we go back to March when we seeded it, we let them grow. And these samples were taken right before termination. So we had no differences between the two cover crop. I have a 14.7 ton per hectare and a 11.3 ton per hectare. So it's a pretty good value. I would say, again, for in ton per hectare, I would say 6-8 ton per hectare is considered sufficient for a good high residue reduced tillage system. At the top, we have the cover crop biomass, and in the graph at the bottom, I have weeds. Here I put grasses, sedges, broadleaves all together. And I could get a 0.3 ton per hectares on the oat and veg, a little bit more for the oat and pea, but just 0.8. So a good control of weeds, and the bare soil is at 8. This is after termination. 30 days after termination, we go look into how much biomass we have left. We have in the field, and you can see here, again, we have the no-till on the left, the till on the right, and the bare soil. You can see there is biomass left on top of the soil, even with the tilled one, because we didn't plow it in. We just break it down and rototill it, but the biomass was pretty substantial, so some stayed on the surface of the soil. Now, previous research found that about 40–70% of the residue generally remains on the surface after a single disc with corn, sorghum, and wheat. It's not the same situation. In this case, we have that after 2 passes of the rototiller, we had a 23% for oat and veg and 30% for oat and peas. And while here I have a 3.5 and both 3.5 ton per hectare in the till part. So we still have biomass on top of the soil. The thing is that a lot of growers here, they call it trash. I have trash left on the field. The problem is not the problem is that usually when we disc it, the residues are not uniformly distributed on the top of the soil. Otherwise, it would work as a weed control, at least some of it. The rototiller does a little bit better job because it doesn't just pile them up in one side or the other one of the field. It's kind of a little bit more uniform, not perfect, but it does. I think it does a better job and disturb less the soil than the disc. Anyway, we are left. We started with 14 ton per hectare. We are about 7 on the no-till and a 3.5 with the till. As far as weeds, we can see they are growing. They did reach the 1.5 or a little more in the oat and veg no-till, so a little less in the pea, but statistically these are not different because the variation was too high. Something that I'd like to point out and that we will see later on again, it's just an observation, is that in general, I see I have more biomass with the no-till oat and veg, but I don't see a better weed control. I always have this bar of the veg still taller than the oat and pea. Statistically, it's not different, but it's something that I notice, and we will see it again here after pumpkins harvest. So I want to see where I'm going to put my cabbages later on. So it's this one. And I have left after 120 days on the oat and veg no-till. I have 6 tons per hectare, little less with the no-till for the peas, autumn peas. And I still have some biomass even on the till part. We are on the tree, a little less on the pea. Pea seems decompose faster. And as far as weeds, I have, of course, a greatest amount of weeds on the bare soil that now are 3.6 tons per acre, and no different, not official or not statistical difference between the rest of the treatment. So no differences on that. And here we can see the pumpkin harvest. Okay, here we have on the left the number of fruit per hectares. So how many pumpkins we made. How much each pumpkin weight here at the center, and then on the far left I have the ton per hectare. So we calculate it based on the area. So as far as number, the oat and veg seems predominant compared to the oat and pea in general. So it seems I'm having a cover crop type of effect. As far as how much these pumpkins weigh, I have the bare soil that has the greatest weight. It weighs more compared to the oat and pea till. The other I'm halfway, but this fact that the bare soil had the heavier pumpkins put the bare soil in the top 3 performers for year 1 pumpkins with the oat and veg, both no-till and till. So I ran the statistics for separately for cover crops and management, and I could see for the pumpkin yield, I could see that oat and veg has the highest yield number of fruit, and in general production. As far as weight, we saw the bare soil had the heavier. And I didn't have much results as far as management, except for the fruit weight. I have no significant difference between management till or not till. Apparently, the oat and veg really push the production. And now we need to jump for a few months after on the cabbages yield. This the beginning of February 2024. We have the same type of graph. We have the number of fruit, the fruit weight, and the yield per hectares. Here things are different. Seems like the cabbages really had an impact. The cabbages yield was impacted by the management more than the cover crop. You see on the far left the 2 bars, the no-till AA. Here we had the greatest number of cabbages on the no-till. Fruit weight was similar among treatment, and oat and pea and bare soil decrease fruit weight, but the no-till blocks really produce really well. And again, I did the same type of analysis, and here I had the opposite, response compared to the pumpkins yield, and I had no differences for the cover crop, but I have significant differences for the management. I have the no-till that had the greatest number of fruit and the greatest production. Now, 2024, this second year of the experiment, now you are familiar with the type of graph I'm showing. Is actually the cabbages were already 2024, but the soil, the new season started with the soil analysis. We can see the soil carbon Right now we are at, was similar to the previous sampling. So similar to October, we are about 1.6, 1.7. We started at 1.4 at the baseline. The organic carbon decrease. We were at 129, 154, and now we are decreasing because we are about 120 right now. And I have a little bit more respiration that we saw in the past October sampling, and now we are around right below 100. So we have some activities from the microbes. So in October we're 32, and now we are in between 69 and 116. So there is no clear differences between among the treatments, but we have an overall. Seems that the microbes are actually working more than before. For the total nitrogen, we had an increase across all the treatment from October to March. The increase is most notable on the oat and veg no-till. So we started the oat and veg had a max of 25. As far as organic nitrogen level, that decreased from October to March across all the treatment. Oat and veg till show the most significant reduction possible due to the increase of microbial decomposition. So it seems like the microbes start working and they are making more nutrients available to the plant. If I have the total nitrogen that goes up and the organic nitrogen that goes down, it means that the inorganic nitrogen is going up. And so that's food for the plant. It means that, that's what I think. We have more active microbial population. Here we have, I need to speed up a little. Here we have the above ground biomass before termination. Is in 2024 is a little less compared to the previous year. We have 5 and 4.5 for oat and veg and oat and pea respectively, and significantly greater wheat biomass in the bare soil at 2.5. While the oat and veg were similar. Here we didn't implement the treatment yet. We can see that there is a similar trend, but lower cover crop biomass in general. This is after termination, and we have, as far as cover crop biomass, we are still at 8, and on the no-till side, and about 3 on the till part. Again, I don't have differences between the cover crops, but I have differences between the management. The weeds trend is similar to the one we saw before. I just put this little graph so you can see how was it in 2023. And the trend is similar. We have most of the weeds in the bare soil, followed by the tilled part, and then the till has the lowest. As far as pumpkins yield, things are a little bit different in 2024. The no-till oat and veg plots at the greatest compared to the till and bare. You can see the A here and the C on the bare soil. Fruit weight was similar between cover crop mixes, so not much differences, but definitely different from the bare soil. The bare soil this year didn't really perform that well, while the oat and pea seems getting a little better. And as far as ton per hectare, we have a similar trend at what we saw. Sorry, I did it again. What we saw before with the cabbages, I have more, I can see I have an effect due to the management, so the no-till versus tillage compared to the type of cover crop. And when I do my analysis separately based on cover crop and management, I can see that because right now I have the oat and veg, oat and pea that both have the greatest number of fruit, and they weight more, and so I have a good total weight ton per hectares. And as far as management, the till part, the no-till part, has performed, was the better performer. So to wrap up everything, we can say that as far as soil, the organic matter remains relatively stable across the treatment, but overall increased. You might think about the bare soil. We call it bare soil, but there were weeds growing on it. And we call them weeds because we didn't seed them, but I think weeds can support the next the cash crop if they are managed the right way, and they provide nutrients too. So that's what I think why the organic matter anyway it grew even in the bare soil. The organic carbon showed a slight decrease, possibly indicating microbial consumption. Total nitrogen had an increase across the treatment. Organic nitrogen showed a slight decrease, possibly indicating microbial consumption, and the soil respiration increased from October to March, suggesting enhanced microbial activity and organic matter breakdown. As far as biomass, above ground biomass, this is our pumpkins here, growing in that rough situation. Before termination in 2023, I didn't have any significant difference between oat and veg, oat and pea mixtures. Bare soil had the greatest amount of weeds compared to the cover crop. In 2024, I could see the similar trend, but with lower cover crop biomass in all the treatments. Bare soil still had a significant greater weed biomass compared to the cover crop treatment. After termination, 2023, no differences in biomass residue weights between oat and pea and oat and veg. Wheat biomass was highly variable. Average wheat pressure did not significantly different, but it was greater in the bare soil. In 2024, we could see a similar trend with no statistical differences in residue weight, but wheat biomass was significantly higher in the bare soil plots compared to the cover crop plots. Wheat pressure was higher in 2024, especially in the tilled plot. At pumpkin harvest, the oat veg no-till treatment has the highest biomass with a 6 ton per hectare. Wheat biomass was lower in cover crop treatment, but still present across the plot. As far as yield, we could see the pumpkins in both year oat and veg treatments consistently outperform oat and pea treatments in terms of fruit numbers and total yield, especially in the no-till system. In 2024, overall wheat pressure was higher, potentially influencing fruit yield and size in some degree. But the trend of oat and veg performing better at oat and pea held steady. Cabbages, the no-till treatment outperformed the till treatment in terms of fruit number and total yield. I added these slides just here at the end. What's the tolerance? Because we always talk about how much biomass I need to have, but how much also tolerance of weed can my crop have? So in general, different researchers had similar or slightly different theory, but this is what I found. The wheat tolerance limit for the pumpkins goes from 0.3, 0.5 ton per hectares to avoid yield reduction, and the cover crop biomass threshold is 8-10 ton per hectare for effective long season with suppression with the no-till system. As far as cabbages, the wheat tolerance limit is 0.5, 0.8 ton per hectare to avoid yield reduction, and cover crop biomass threshold is in between 6 and 8 tons per hectare for an effective short season with suppression no-till system. Cabbages are quick, especially the Napa cabbages. That's why we chose them, because I needed something that could fill up that space, but it still give me the time to plant another cover crop and have my summer cash crop. So I think there is a tolerance, weed tolerance. I think it's really, really important to manage weeds. You probably already know, really at the beginning of the life cycle of our cash crop. What it's called weed-free period is that period that goes depends from crop from 1 week, 2 weeks, 1 month, from when we seed or we transplant, that the plants that cannot have competition, that will ensure to have a good yield. Once that month is passed, maybe I don't need to pay that much attention to all the weeds that grow, because my plants will be already established. So in conclusion, the results indicate the cover crops effectively manage weeds pressure and contribute to enhance soil health with no-till system, offering clear benefits in terms of biomass retention and cover crop yield, especially in cabbages. The study suggests that integrating cover crop, especially the no-till system, can provide sustainable long-term benefits for both soil health and crop production. I have a few pictures that I want to show you. And so here we have some of the picture of the pumpkins in August. And here on the right, this is actually another trial, but this is the rye that we terminated. And I really like this type of, and you can see the bare soil in the back. And we were comparing on zucchini, pepper, and eggplants, and I think there is another webinar about that. And here, how it looks right after crimping it, really green, and it will dry off. This is actually the HSP, our Healthy Soil Program, right after crimping it. And here we have the two sides, the bare soil and I think this is I see the batch. And now if you have questions, please feel free to ask, and or you just send me an email. I have my email address there. Now, as far as timing, we have 2-3 minutes, question and answer. I thought this webinar was supposed to be about pumpkin cover crop strategies, and I thought I did talk about pumpkins. I'm surprised the focus on oat. I usually hear about rye being grown as cover crop with pumpkins rather than oat. Do you have any experience to comparison with to research results with rye? I honestly don't. We tried rye with other crops, and we had amazing results. I really like the rye. And but I didn't try with pumpkins, and now I will need to decide what type of cover crop to do for the next year. I was thinking to use the triticale or wheat and the crimson clover for this experiment. I need another, maybe peas too, because I'm looking for a cereal that can be terminated with the heat instead of the cold, as they do in the eastern part of the United States. All right. I have a last minute question. How did you use a roller crimper on a raised bed system? Yes, we did. We did it on, we have a specific roller crimper for the 64 inches bed, but I'm using the flat ones for for the flat and for the raised beds. And honestly, the raised beds, we have a great results, especially with the cover cropping system, because it seems like when I bed up, the effect on the soil health is more quick compared when I work on the flat as we did for the pumpkins. But if you have more question or you want to talk about some cover crops, please feel free to send me an email. And well, thank you for being here and have a great rest of your day.